So, Mark, thank you for the introduction. My name is Todd Davidson. I work at the Energy Institute at the University of Texas in Austin. I'm going to give you a very quick introduction to a project that we completed in partnership with the Department of Energy, specifically Oak Ridge National Labs, to look at the cost effectiveness of mobility services versus personal car ownership. So getting right to the cut, right to the chase, the question is it make sense for you to get completely rid of your personal car and use mobility services 100% of the time for every single trip that you take? And by our estimate, the answer might be on the order of around 20% of drivers in the United States might be economically advantaged by using mobility services. Of course, the real answer is more complicated than that. I very purposefully, shake my hand because there's a lot of uncertainty here. There's pretty big uncertainty bars. But when we start talking about orders of magnitude, or at least metrics in terms of maybe tens of percents, this is probably in the right order. So let's talk more about some of this detail in terms of, I guess, the challenge that we're facing. I think this picture speaks 1,000 words in terms of the challenge. There's a lot of challenges embedded in this, but the one that I want to highlight for you is the amount of time that we spend behind the wheel every single year. If you're not aware of it, we spend hundreds of hours every single year behind the wheel of our car, and that time is worth something, and that's specifically what I'm going to talk to you about today. Because mobility service companies, what they're doing is basically you hand them money and they hand you time. That's basically what their business model is. And so that transaction, there's a question there whether or not that's enough or if that's worth your time to do that, to hand over that money to them. And many people are suggesting that this is the solution for a lot of those problems, right? We pair Uber and Lyft with automated transportation, in particular electrified transportation, in order to solve a lot of these problems. There's a more basic question, though, which is the question that I'm asking, which is whether or not Uber and Lyft can compete economically today. And I think one of those things that we need to emphasize is to make sure that you fully understand how much time or how much money we're actually spending on our personal cars. So we add up ownership costs, maintenance, fuel, parking, and particularly lost productivity, which is the thing that I keep hammering home here. You could easily be spending over $15,000 every single year if you actually talk about monetizing that time. Of course, that's a very subjective question, which I'm happy to talk about and get into in more detail here in just a moment. So this economic model, I could show you all of the equations, but they're basically just going to look like a bunch of Egyptian hieroglyphs, so we're not going to do that. Instead, the economic model, what we're doing is basically just taking all of these inputs and comparing them to try to consider whether or not one or the other is more advantageous. And that value of time, what do I mean by that? Well, because it's subjective, if you imagine you're a really well-paid attorney, if you're riding to work, you might actually be getting paid for that time. So there's clearly a value there. If you are, say, wanting to read a book, is it worth your time to read a book? Is it worth your time to maybe even just close your eyes briefly, I have a 10-month-old daughter at home, and I can sympathize with the fact that even just closing my eyes or just unplugging for 10 minutes can be worth something that is non-trivial. And so there is, and that's a big driver for how these equations begin to play out. So I'd be happy to field questions on that once we get to it. This is one of the ways that we visualize the economic model results. It's always hard to kind of visualize economic models, but this is one of the ways that we do it with heat maps. So the things I want you to pay attention to is that blue means hire mobility services and the red means own a car. And the other thing I want you to pay attention to is the y-axis, which is value of time in terms of dollars per hour. And as you move vertically along that, you begin to get into the blue very, very quickly. Now, if you watch the slide, watch the right-hand figure, we're now going to lower the cost for the mobility services. So we're going to lower it from $1.50, which is what this is showing, down to $1. And we see this. So the diagonal line drops. We now see a whole lot more blue, less red. The point being here is that mobility service companies recognize this. Uber and Lyft understand that if they get the price below about $1 per mile, they're going to become really competitive with personal car ownership, or at least more competitive. Now, the other critical thing I want to make sure that you understand is that median car price in the United States is around $31,000 for a new car. And median wage in the United States, according to the Social Security Administration, is $15 per hour. That means the vast majority of people are right near the intersection of those two dotted lines. So this diagram, these heat maps, can actually visually distort what the conclusion really is. Because the conclusion really is that most people should continue to own their car. There's very few people in the top right-hand corner of that figure. All that really, really deep blue, very few people are up there. Most people are near the intersection of these lines. And that's one of the takeaways we need to have. This is another one of the ways that we display our data. I know this is complicated, but if you can just track the red line, is what I want you to pay attention to. So all of those red triangles. Another way we handle the uncertainty in all of this economic modeling is using Monte Carlo simulations. Each one of those red triangles is a unique Monte Carlo simulation that has roughly 1 million samples of the data sets that we have. And the red or the blue shaded region is the fair prices that transportation network companies were offering in 2017. And from this, we can begin to see that we have this range of around 10 to 30% of the population might be economically advantaged by using mobility services. Of course, this assumes people are rational economic actors, which is not necessarily the case. It's a critical issue. Again, happy to talk about this more in terms of what that means. So that's why I'd rather say, well, it might be on the order of around 20%. Of course, we're going to have plus or minus error bars in this whole thing. Why am I doing this, right? I'm an energy guy. Why are we looking so much at the economics of this question? Well, economics begin to often drive consumer behavior, and from consumer behavior, we can then look at sort of potential changes in energy consumption. And one of those changes, which has now been noted by Mark and others, is the potential for vehicle electrification. Well, mobility services might drive or at least accelerate vehicle electrification, in part because people realize, particularly Lyft and Uber and others, if they ever end up operating a fleet of vehicles, they realize that electric vehicles have the potential to lower the total cost of ownership, as well as CO2 emissions, and improve basically their social contract to operate, right? So that's an interesting aspect of this that may drive electrification faster. The map that I'm showing you on the bottom left-hand side is from a study that we have at the University of Texas, at the Energy Institute there, called the Energy Infrastructure of the Future. And what I've modeled here is electricity demand for increasing vehicle electrification for every single county of the United States. And so what we can get from this, or the takeaway that I want you to have from it, is that energy demand is a regional question. And so if we have increasing vehicle electrification, this is going to change different regions in different ways. And I think one of the really interesting aspects of this type of work, is that we sort of start from this basic question of consumer behavior. It then moves to potentially changes in transportation hardware, which then impacts potentially our electric grid. So it's this really big, complicated challenge, right? And that we need to bring a bunch of people like this together to try to solve, or at least get some insight on. So some quick closing thoughts, right? The main takeaway is roughly maybe 20% of drivers could be economically advantaged. Shared autonomous electric vehicles, in my opinion, are not the only solution. There's a lot of ways that we can improve our transportation system, but maybe there will be a future where SAEVs really are playing a major role. I would pay attention to these guys, electric scooters. They are all over Austin, and there would be more of them if the city allowed it. They are beginning to gobble up a lot of short-haul trips in cities that Uber and Lyft often are relying on. And Uber and Lyft and others are beginning to plow money into this space because it's real. And they basically are shared electric vehicles, so pay attention. Cars are personal. We often have our identity embedded in them. There's a lot of emotion in our personal vehicles, particularly for older generations and even my own generation. So people are not necessarily economically rational actors when it comes to making decisions about their cars. Of course, customers might change. Toyota and GM and others, Ford, and many people are investing in this space because the customer might change in the future. This is an opportunity for them. And I will leave you with, consider about the subjective value of your time. Whether you realize it or not, I actually think it's driving a lot of the decisions we make in the transportation space. So I do want to say thank you to Oak Ridge National Labs for supporting this work. And last, if you have any questions for me after our discussion, you can reach me at my email here or on Twitter at @FToddDavidson. So thank you very much for your time. I'm looking forward to the discussion.